Hello everyone, welcome to my channel. So today we are going to discuss another LeetCode problem, and the problem number is 2761. That is a prime pairs with target sum. Okay, so what is given in the problem? Let's quickly discuss that. So here we are given an integer n, okay, and what it says that two integers like x plus y form a pair it's a pair and which forms a prime number. Okay, so these are the constraints, like if one is less than equal to x, less than equal to y, less than equal to n, and x plus y is equal to n, and x and y need to be prime. So this way, so if I just want to simplify a problem with an example, so let's say we are given an input number n, that's it, and uh, and what we have to do is we have to form, or we have to find out the pairs of prime numbers in a such a way that when you sum up those two numbers, that pair, it gives you the n value. Okay, so for example, here to get the 10 in the range of 1 to 10, what you can see is, of course, like 1 and 1 is not a prime number, so what we have to do, and of course the 0 as well, so what we have to do here is 3 and 7 both are prime, and when you sum up these two numbers, it gives you the value 10. Similarly, 5 comma 5 is again another pair, and both of them are so 5 is again the prime number, so sum of this is 10. So that's why the answer is 3 7 is one pair, and another is 5 comma 5. For n is equal to 2, again as I said, 1 is not a prime number, so you cannot you cannot have a pair which gives you the value or sum is equal to 2. So that's why in such case you have to return the empty array, and these are the constraints, like 1 is less than equal to n, less than equal to 10 to the power 6. So in order to solve this, so one there are few observations you can always keep in mind. So whenever you are asked to find the prime number, okay, so always think about one of the famous algorithm, that is the Sieve of Eratosthenes. Okay, so in this what we do is, what it does is it forms a one-dimensional array. Okay, it forms a one-dimensional array, and it contains all the list of prime numbers, as well as so basically it's just a boolean array. Okay, and which keeps like whichever numbers are prime, we keep them as a mark as a true, and whichever numbers are non-prime, which we keep them as a false. So that's one possible solution. Of course, there is another way we can do it with the binary search, but just to keep it easy, we can go with this Sieve of Eratosthenes algorithm. Okay, so once we form this array which contains the list of prime numbers ranging from 1 to n, okay, so actually we keep one more extra buffer because the array starts from the 0. Okay, so we mark all the list of we fill the array with primes and non-primes with a boolean value. Okay, once that is done, then another observation what we can see here is how to find a pair. So if you look at this expression, x plus y is equal to n, so if I just want to write this, x plus y is equal to n, what we can do is we can do it something like this, n minus y. So if I just get a value of this y, then I can say reduce, subtract it from my n, and then I can get another value as a x. So that way I can make my pair xy. Okay, so these are the two key observations we have in this problem. So what we have to do here is, okay, first of all, first step is we have to form the prime array with the help of Sieve of Eratosthenes. Okay, once that is done, then we have to iterate from 1 to n, and we have to check for that particular, like the prime in the prime array, if that ith value as well as the prime of n minus I, both are so if what are the value for these two indices? If these are primes, then we can treat this as a one pair and put it into the output list, or you can say list of list. I think yeah, it is list of list. So we can put it into the list, and then this list again we have to put into the parent list. So that's the idea of this problem. So just two observations here. I will quickly summarize. What we have to do here is, first we have to form this primary the array which contains the primes as well as non-primes numbers, and then we have to iterate through this loop, and we have to check for each and every indices whether what is the value for that particular index and the n minus ith index. If both of them are prime, then we can treat it as a valid pair. So let's quickly look at the code for this problem. Yeah, so first of all, what I am doing here is, here I have I am initializing the boolean array, and there here I have a function prepare the Sieve of Eratosthenes. Okay, so in this function what we are doing is, this is a standard algorithm. You can find good amount of blogs over the internet, check out those. So initially we are filling the entire array assuming that all the elements are prime. So this is the first step. Then what we are doing is, we are marking the 0, 1 as a non-prime, because those are the non-prime numbers. Okay, so that making them as a false. Then this is the standard algorithm. So whatever the numbers which are multiple of the 2, for example, then we are marking them as a non-prime, because 2 is a prime, and whatever is the multiple of it, those are divisible by 2, so those are of course not a prime. So this thing we have to do till the end. So here this is the standard piece of algorithm we have. Okay, what it simply does is, if the number is prime, then find out the multiple of if that number is prime, then find out the multiples of it and make them as a non-prime. So once that is done, once your this prime array is formed, then what we have to do is, we have to iterate through this primes array and check if the number and the n minus number both are prime, then add it in the output list. So here I am preparing the list of list, then starting from the I is equal to 2, because here of course for 1 and 0, the output will always be the empty list. Okay, so then the similar case for the 2 as well. So here what we have to do is, we don't need to like traverse the entire array, because if you get the left the half of that side of the number, then the remaining side will directly gives the answer. Okay, so traversing from I is equal to I till the I is less than n by 2, then here we are creating a sublist, then we are checking what is the value at the in the prime array for the ith index. If it is a prime, similarly the another another element of that pair, that is n minus I, the same formula as I said, x plus y is equal to n, so x is equal to n minus y. So this the same thing. If both of them are prime, then we are adding them in the sublist, and finally that list gets added to the final list. And similarly we are incrementing the index, and finally we are returning the array. So that's the solution of this problem. I hope you found it helpful. Yeah, that's it. Thank you.